Welcome everyone. Good afternoon. Hope you're having a good re:Invent so far. My name is Prasad. I'm a product manager with AWS. And today's topic is predictive scaling. We'll start with an introduction to auto scaling and then jump right into predictive scaling and its benefits. After that, I have Cal Patel from Genesys joining me on stage. Just a reminder, this session is being recorded and will be posted on YouTube, and the slides will be on SlideShare. So let's get started. So auto scaling is a free service that has been designed to automate capacity provisioning and make it as simple as possible. So currently 8 services are supported by auto scaling: EC2, ECS, EMR, EC2 Spot Fleet, DynamoDB, Aurora, SageMaker, and AppStream 2.0. Since launch, autoscaling has taken tens of billions of actions on your behalf, increasing your agility to respond to your customers' changing demands while saving you time and money. Recently, we launched custom resource scaling, which enables you to scale any resource on AWS or off of it. And customers and partners are using custom resource scaling in interesting ways. We have Kenzen, who's designed auto scaling for Genesys using custom resource scaling. To give you an overview of auto scaling, it can be used in 3 different ways, if you will. You can put a bunch of EC2 resources in an auto scaling group and scale them through EC2 auto scaling, which is accessible through API or the console or CloudFormation. And for the other non-EC2 services that I mentioned in the previous slide, you can scale them using application auto scaling, which is available through the API or CloudFormation. It's also accessible through the individual resource consoles. For example, DynamoDB console can be used to configure DynamoDB auto scaling. AWS auto scaling, which is the third way, it's been designed to scale multiple resources at the same time. So it allows you to search and scale multiple resources with a single scaling plan. The application can be defined either through a CloudFormation tag or simply a CloudFormation stack or simply through a tag, and then you can group them together and create a scaling plan. A scaling plan can have a mix of EC2 and non-EC2 resources, or it could be a bunch of EC2 resources but put in separate auto scaling groups. So the AWS Auto Scaling console has been specifically designed to make scaling simpler and easily accessible for everyone with pre-configured options such as optimize for cost, optimize for availability, or a balance of both. So let's talk about EC2 auto scaling, because today's predictive scaling is about EC2. So before last week, if you wanted to scale EC2, you could do it in 3 different ways. Manual scaling, which is about manually changing the capacity of the auto scaling group. It's the least automated. In fact, it's not automated at all. But it comes in handy if you have one-off events that you want to respond to. Then you have scheduled scaling. It allows you to set capacity based on a schedule. So you may have workloads with, say, 9 to 5 patterns or weekday, weekend patterns. And scheduled scaling allows you to set the capacity in advance with a detailed schedule. Dynamic scaling changes the capacity dynamically, as the name implies, based on the rules you set. So here you have 2 options. The first is step scaling, which changes the capacity in step functions. So you could have a configuration such as that specifies adding 5 instances when the CPU utilization goes beyond 60%, for example. Or you could say add 10% more instances. So that's step scaling. And then the second method of dynamic scaling is target tracking, which is like a thermostat for your resource utilization. You could set up the CPU utilization to be 60%, and then target tracking will automatically add and remove instances to keep that as average CPU utilization at 60% for that auto scaling group. So like I mentioned before last week, these were the 3 methods. But there's always more we can do to further simplify capacity management. Some of you have said, well, the current methods do a good job of giving us capacity as the traffic changes, but we actually want capacity before the traffic changes. So that's where we launched predictive scaling. So there could be many reasons why you want capacity before the traffic changes. The first example could be that you have spikes in traffic that are too steep, or you could have warm-up times for your instances that are too long. So having capacity before the actual change in traffic can be very useful in these cases. So last week on November 20th, we launched predictive scaling. So as humans, we're always trying to predict what we can predict, whether it be weather and traffic that affect our day-to-day lives, or resources that we consume like time, electricity, and water. Prediction always results in better planning. So why predictive scaling? There's a few reasons why we could scale before impending change in application traffic. So at Amazon, when we looked at our auto scaling groups and the traffic going into those auto scaling groups, we realized that 40% of the traffic is cyclical. And when we started talking to our customers, AWS customers, on their auto scaling groups, the proportion was somewhat similar. 40 to 50% of auto scaling groups out there have cyclical traffic. So when we know the nature of the traffic, we can take advantage of it for managing capacity. In fact, many customers that we talk to are already using scheduled scaling to codify their knowledge of their cyclicality in their auto scaling groups. So it would be great to automate that, something that is being done manually to automate that. Then there are applications with long warm-up times that I mentioned earlier. It could be because of many reasons. It could be because you have database servers that need data to be copied over from another place, or you have longer configuration times where many applications may have to be loaded even after the OS is available for the instances to start taking traffic. So if we can predict the traffic in these cases, we can have the capacity beforehand. Another reason is how to control or controlling how auto scaling responds in the case of a temporary external outage. So as it is important for auto scaling groups to respond to changing traffic, it is just as important for them not to respond to short-lived outages and cause unnecessary fluctuations in capacity. So in all the above cases, knowing traffic patterns in advance can enhance your auto scaling experience. So let's look at the benefits of auto scaling, how it can enhance your auto scaling experience. So it can make your scaling faster by scaling up in advance. So periodic spikes in traffic that have a daily or weekly pattern, if you have traffic like that, you can set up predictive scaling to scale in advance of the spike. Having capacity available and ready to take on more traffic before the spike occurs makes auto scaling faster than ever. Auto scaling becomes more accurate as well with predictive scaling. Knowing what the usual traffic for that day, for any time of that day, is helpful to recognize an unusual pattern and respond to it appropriately. Then the third benefit is that predictive scaling makes auto scaling configuration simpler. In many cases, customers are using scheduled scaling and dynamic scaling together for various reasons. Suppose you have a weekly traffic pattern. It might need 100 plus scheduled scaling actions to cover the pattern. And suppose you deploy that application in a new time zone, or you launch a new feature in that application that suddenly becomes popular in a particular time zone, then your weekly pattern changes, and then you'd have to manually configure all those 100 plus scaling actions to the new pattern. With predictive scaling, you never have to do that again. You basically, the predictive scaling algorithms will learn the new pattern and change the scheduled scaling actions automatically going forward every day, and they do that every day. We'll look at that in more detail. So in that way, predictive scaling makes auto scaling configuration simpler. I'd like to present 3 use cases to discuss the benefits, to showcase the benefits of predictive scaling in a practical setting. The first use case, here's a microservice in Amazon.com. So here we're showing 4 days worth of requests per minute metric. As you can see, there are multiple spikes in a day. And in many cases, a spike is immediately followed by another spike. So in this type of traffic, if you have, say, a 15-minute warm-up time, you might have to have extra capacity in place in order to accommodate those spikes, or you might risk a poor customer experience. So let's see how predictive scaling handles this kind of traffic. So what we've done here is that we've taken 14 days worth of historic traffic and predicted it into the future. The forecasting algorithms in predictive scaling forecast 2 days into the future. So we've overlaid multiple forecasts here to show the 5-day forecast in this graph. So as you can see, the algorithms predicted the spikes fairly accurately. So in this step, all we're doing is that we're taking the load metric and forecasting it in the future. And the load metric it's independent of the size of the auto scaling group. It's an external metric, to be precise. So now let's see how auto scaling takes this forecast and uses it for capacity. So what the algorithms do is that they take the forecasted load, and then they forecast capacity based on that load. Excuse me. And they do that for the next 48 hours. So it's an hourly forecast for the next 48 hours. So there's 48 pieces of forecast into the future. So what we see here is that the capacity, which is the white line, it's overlaid on top of the actual load and the forecasted load. And the scale for the capacity is shown on the right of the chart. So with predictive scaling, you get an automatically set of pretty sophisticated scheduled scaling actions in advance that mirror your traffic pattern. Now let's zoom in into the spike and see what exactly is happening here during a spike. This is the spike that has been blown up for in terms of time. The pink line is the actual load. The green line is the scaling response without predictive scaling, and the white line is the response with predictive scaling included. So this particular auto scaling group had an instance warm-up time of about 15 minutes. So a couple of points to note. In steady state, both the scaling response with predictive scaling and without predictive scaling are somewhat similar. But with the 15-minute warm-up time, without predictive scaling, the capacity takes time to catch up with the variations in the spike. It's pretty much a straight line. But with predictive scaling, we're able to see variations in capacity that mirror the shape of the spike. So this illustrates how predictive scaling combined with dynamic scaling makes auto scaling faster, especially during spiky traffic. I'd like to illustrate a second use case using another microservice in Amazon.com. This one has a daily and a bit of a weekly pattern as well, as you can see from higher traffic on certain days. And the right side of the chart, the orange line, shows the forecast overlaid on top of the actual traffic. So if you see the actual traffic, there is a sudden dip for a brief period of time that recovers quite quickly. But the predictive scaling forecast traces the usual traffic pattern for that time of the day and day of the week. And so you see the forecast overlaid on top of the actual traffic. I'd like to zoom in on the capacity overlaid on top of the forecasted load, and show you what happens. So what happens here is interesting. In the case of predictive scaling, it sets the minimum value for the minimum capacity for the auto scaling group. So in this case, the dynamic scaling doesn't take the capacity below the minimum, and hence you have this guardrail kind of a functionality that we can zoom in and see. The pink line shows the actual load. The green line is the auto scaling without predictive scaling, and the white line is the response with predictive scaling included. So a couple of things to note. One is that without predictive scaling, the capacity takes longer to recover. Even after the spike has recovered, there is a bit of a lag obviously because of the warm-up time, etc., to recover from the dip, I mean. But with predictive scaling, the untimely dip doesn't have any effect on the provision capacity. So in this case, predictive scaling is acting as a guardrail for dynamic scaling and making it more accurate, the overall scaling more accurate. Let's look at another microservice. This is the third use case. Here we've taken a microservice and we artificially increased the traffic week over week. So week 2 traffic was 20% higher than week 1, and week 3 was 20% higher than week 2. We did that to illustrate a service where over time, due to either increased adoption or increased usage, any schedule scaling actions that you might have configured will quickly become dated. Now, this may be an extreme example where traffic is increasing week over week, but it's intended to mimic deployments that will change your pattern. You see that if you had set up a detailed schedule scaling actions along with your dynamic scaling, it would pretty much have to be reset up again. In this case, you could just increase them by 20%, but in the real world, it's not as clean. But the main point I want to make is that with predictive scaling, the forecasts quickly catch up after about a day of showing a lower forecast. Even though the last 2 weeks forecast is considerably lower than this week's, after a day of forecasting, they catch up to the new levels that the actual traffic is. So in this case, it's adding simplicity to your configuration by removing the need for doing manual schedule scaling actions. Let's look at some of the key aspects of configuring predictive scaling. The first key metric is the load metric. This is the incoming load into the auto scaling group. We use last 2 weeks of data for our prediction algorithms, but predictions will be done with as little as 1 day worth of data. And this load metric is independent of the size of the auto scaling group because it's an external metric. Then you have the scaling metric. This is the metric that you would typically use with your target tracking to configure target tracking. It denotes the resource utilization levels of the auto scaling group. This scaling metric is also used by predictive scaling, not just target tracking, because it uses the scaling metric to figure out the capacity from the forecasted load. We'll look at that in the next slide. So the scaling metric is used both by dynamic scaling or target tracking in this case and predictive scaling. There are other optional configurations that we hope are useful to you. You can configure how much in advance you want the predictive scaling to scale your capacity before traffic. So you can say 20 minutes in advance. So knowing the forecast, it will have the predictive scaling will ensure that you have capacity 20 minutes in advance, so that the instances are up and running and ready to take on traffic. So that's a configurable parameter in predictive scaling. You can also configure how predictive scaling handles your max capacity. So you could have an externally configured max capacity for the auto scaling group, but predictive scaling might predict that you need a capacity that's higher than what you've configured. And in such cases, you can specify both options. You can say, no, stick to my max capacity that I've configured already, or increase the max capacity to what you predicted, what predictive scaling has predicted. So both options are possible. You could also use predictive scaling or the AWS Auto Scaling scaling plan settings to configure whether you want to replace external target tracking policies that you've set somewhere else. So if there's already an existing target tracking policy, you can replace that with a new scaling plan that includes both predictive and target tracking policies together. Finally, there's also an option to do forecast-only mode for simulation of schedule capacity. So in this case, the predictive scaling algorithms will generate the actual capacity, but they're not applied to the auto scaling group. So you can use them for various things to understand the pattern of your traffic for the next few days, etc. So how does it all work behind the scenes? So what we have is a model that has been trained on billions of data points from Amazon.com. Makes it a very effective forecasting model. It takes the load metric and forecasts it for the next 2 days. At the same time, predictive scaling performs regression analysis between your load metric and scaling metric, and then schedules scaling capacity for every hour for the next 48 hours. And the whole process is repeated every day. So, in the meantime, dynamic scaling continues to make adjustments on top of the schedule capacity to result in faster, simpler, and more accurate auto scaling. Finally, I want to point out that you can use predictive scaling with or without target tracking. So when it's used with target tracking, predictive scaling sets the minimum capacity, and target tracking will adjust the desired capacity dynamically. And without target tracking, predictive scaling only sets the minimum capacity, so scaling in has to be handled somewhere else outside of the scaling plan. So we have been in private beta for the last several weeks, and Genesys has been one of our beta customers. So it is my pleasure to invite Cal Patel, Principal Architect at Genesys, to join us on stage to talk about how predictive scaling benefits Genesys PureCloud.
Thanks, Prasad.
Yeah.
All right. Hope you guys are having fun. And that's bright. All right. So Genesys PureCloud. Genesys provides a contact center infrastructure. We've been recognized 23 times by Gartner. And in 2018, we were recognized as the leader in contact center offerings. We have 3 main solutions: PureCloud, PureConnect, and PureEngage. Actually, let me go back. So PureCloud, for this talk, I'm going to focus mainly on PureCloud. It's 100% AWS deployment. So this is a very high-level bird's-eye view of PureCloud deployment. Single PureCloud deployment is contained within a single region. And what you're seeing is each box there represents a microservice or our data tiers. And what the lines between them is the communication happening between those, between the microservices and the data tiers at any given time. To give you an idea of the scale, we're about 200 plus microservices. We're deployed in 5 AWS regions. We follow the DevOps philosophy all the way. You build it, you own it all the way. You own it in prod, you maintain it in prod, everything all the way. We're knockless. What I mean by that is we don't have a knock. It's the service teams that get woken up in the middle of the night. It's the service teams that see the alerts and pages. They're the ones who run the playbooks if anything needs to happen. And we're immutable. So what I mean by immutable is we actually bake AMIs and promote the same AMI across environments and across all deployments. So to give you an idea, during our build process, we actually, before we release an AMI in any environments, it goes through all the validation, security, testing, and all other stuff before it gets released out. And we are PCI and HIPAA compliant on top of that. So to go more into details, at any given point, we're about 7,000 instances. During peak hours, we've seen it pass about 10,000. We have about 3,000 ASGs and about 2,500 EC2 images at any given point. Here's our pipeline. This is a quick summary of our weekly pipeline. We do about 1,500 deploys a day, 500 in test, and about 350 in production. So when you think about it, 350 deploys in production across 200 plus microservices. It's quite a bit of churn on a weekly basis. So when we started talking about predictive scaling, we started looking at what really do we want to get out of it. And the first thing was our main focus is to provide a highly available platform while optimizing for cost. Second, due to security and compliance reasons, we cannot fail over across regions. So every region has its own, or every deployment has its own unique patterns, because every deployment has a different set of customers, and they all each customer brings a unique set of patterns with them altogether. And this year alone, we have seen triple-digit growth in platform usage. And as a result, we spend quite a bit of time optimizing our capacity planning, tweaking our auto scaling groups and things like that. So we were pretty excited to jump on and play with predictive scaling when it became available. So before we go into detail, here's a quick overview of a single microservice across 3 deployments. You could see in US East, we have about 12,000 requests per minute average. In Tokyo, we have about 3,000. And in Ireland, we have about 31,000 requests per minute. You would think Ireland's our busiest deployment. It's not. It's actually US East is by far the busiest one. In this specific case, we have a single customer that has a very unique usage pattern, and that results into a very different workload for this microservice. And you can tell, because service teams own everything end to end, they spend a lot of time to stay ahead of this kind of changes in usage patterns and things like that. So to go further, earlier this year, we had a small incident or accident, and I'm going to talk through it a little bit, and I'm going to talk about predictive scaling and tie it all together towards the end, hopefully. So walk through it very quickly. We normally deploy during off-peak hours, and we deploy across all regions when we roll out new changes. In this specific case, we did the rollout, all the tests passed, everything looked great, so we went home. We came in the morning, realized we had some issues in one of the regions, and we decided we were going to roll back. We didn't only roll back in that region, but we decided we were going to roll back across all regions. So in US East, we rolled back, and about a short period after that, we saw a very small spike in error rate. If you notice, it's less than 0.4%. But in this specific case, it's very time sensitive, and it happened right during the peak hours. So it was enough for our customers to notice and call us. And we got quite a few support cases open because of the small spike. Now, because of the small spike in this service, we had multiple circuits open downstream as well. So it trickled down the solution quite a bit. And as you can see, we recovered fairly quickly in this case. And then we deployed a fix very quickly after that. What I'm going to do now is I'm going to replay the same incident from ASG metrics. In this specific case, I'm using the total instance count. Every different color is a different deployment on this picture. So as you can see, we had a deployment off hours. We roll back in the morning. But one thing I want to point out here is if you see, we scale up every day using scheduled scaling. And it's very static. So in this specific scenario, what happened is we had scaled up, and then we decided to roll back. And when we rolled back, our scheduled scaling did not re-execute because it was after the time period. And as a result, our min values on the ASGs weren't set to what we would expect them normally. And because of that, target tracking scaled us down quite a bit. And then when the morning spike came in, target tracking decided, hey, you need to scale up to handle the capacity quite a bit. So what happened is we tried to double, if not triple, in capacity very quickly. Our compute tier came up fairly fast. However, our caching and data tier were lagging behind. So the error spike you saw in the previous picture was really the data tier not being available fast enough, and as a result, we dropped few requests on the floor. Now, during the investigation, we fixed the ASG, and we were able to continue through just fine. So, to give you an idea, we started playing with predictive scaling, and I'm going to walk through how our daily workloads, our daily scale-ups have changed with predictive scaling a little bit. So as you noticed, normally we just scale up and we plateau all the way through, and then we scale back down. On the second day, you see we actually enabled predictive scaling, and you can see the min values going up and down, and it looks a much nicer curve, the rest of the graph. So the bottom picture is actually group min size and service instance count or desired capacity. What's interesting here is it's a combination of predictive updating the min size and dynamic updating the desired capacity. And you can see we actually tweaked fairly well, where we could handle the first half of the load fairly easily, and then during the second half we get quite a bit of spike, and then target tracking takes up and we scale quite much higher than what we expect. Now, this was enabled with a very small data set. So this did not have 2 weeks of data that Prasad talked about. It was about 48 hours of data. So it's a very small data that we enabled and we were playing around with. So as you see on the second day, the predictive decided we don't need to scale up as early. And as a result, the very first spike in the morning, we didn't have enough capacity, and target tracking scaled us up pretty high. Interestingly, after we handled the first spike, target tracking tried to scale us down. Predictive had caught up and changed our min value to the right capacity. We didn't really scale down any further. We stayed at the provision capacity. And then when we had the second spike, we were able to scale up fairly well. Now, one thing I want to point out is the scale up. If you look at the first scale up, it's straight up. That's where we run into a lot of issues, where your compute tiers, it's very easy to bring it up online and it's all available, but your caching and data tiers are always lagging behind. And this situation also creates a lot of surface area for things to go bad. You run into a lot of race conditions and all kind of issues with it. And if you look at the graph on 11:15, predictive adjusted the min value fairly well, and that scale up is much more gradual. And it actually was very much in line with our data tier scaling up and whatnot. So it was a much more controlled scale up. So in hindsight, everything's simple. Hindsight, we always think we could have avoided stuff, but in this case, I really think that if we had predictive scaling available to us earlier and we had it enabled, we probably would have avoided an incident altogether. So we've been playing with it for a little while, and here are some of the lessons we learned on our way with predictive scaling. First, we use red, black, blue, green deployments, and as a result, our ASGs never have enough data. If you are deploying very frequently, you never have enough data to actually enable it. So we actually work with Prasad and team to actually put some automation in place to carry over custom metrics and historical data to actually use custom metrics for forecasting and enable it. Second, most of our services were using ELBs. We found out ELB metrics are not supported, so we had to convert some of the microservices over to ALB. So combination of predictive and dynamic, we feel fairly comfortable to let it auto adjust our capacity, but we still need to monitor our data tiers very closely. And as a result, we get pretty close to 100% autopilot, but we're not quite there. So what's next for us? Rollout of predictive scaling. So we're going to continue talking to more teams and try to enable it as far in our solution as we can. Forecast only option is a very interesting option. We use it we've been using more and more since we started playing with it. We use it not only to validate the plan of action before we enable it, but we actually use that and use that to have a lot more cost optimization conversations, especially around reserved instance capacity and things like that. And third, what it's really allowed us to do is play around with the custom metric for adjusting our capacity. So for example, you could use this upstream service load metric to scale a downstream service, and in the forecast only mode, you could verify how close it is it something you could actually enable or not, and you could experiment quite a bit with your custom metric for load and capacity adjustment. So forecast only has been pretty fun to play with. I highly recommend it, and I'm going to hand it over to Prasad real quick.
Thank you, Cal. So predictive scaling is available today in 5 regions: Virginia, Ohio, Oregon, Singapore, and Ireland, and with more regions to come very soon. So if you'd like to get started, you can go to aws.amazon.com/autoscaling. You can start with creating a scaling plan. It's very simple to use the console and create a scaling plan. So thank you very much for your time. We're going to be hanging around here for a bit, so if you have any questions, we can address them on the side. But thank you for coming. And please remember to complete the session survey in the mobile app. Thank you.